Hello, I'm Jin Lee.
And I'm Zian. Today we'll be presenting on low energy building analysis.
The net zero building that we are analyzing is the Frick Environmental Center. The building is located in Pittsburgh, USA and has an area of 15,570 square feet. The building is completed in 2016, designed by renowned architecture firm BCJ.
Oh, I see. So what's so special about this building?
The building is designed and built by using 40% less energy than comparable benchmarks and also set goals to be net zero energy and water.
Oh, I see that this building has been awarded LEED Platinum. Very impressive.
Yes, indeed. Let me show you a video on the building water efficiency as water consumption is reduced then less energy is used. Emissions are reduced and we move toward net zero.
Water is an important natural resource that Pittsburgh is lucky to have in abundance. We receive nearly 40 inches of precipitation annually. Much of that falls during heavy rainstorms that can overwhelm our antiquated sewer system and cause damage through flooding and erosion. With climate change, and our region is predicted to see both increase in overall precipitation and more frequent intense storms. At the Frick Environmental Center, we have two goals with respect to rainwater. First, to meet the Living Building Challenge net zero target, we need to capture at least as much water as we use on site. Second, we need to return water to the environment in ways that protect the ecosystem and human health and eliminate the burden on our older sewer system.
As you can see, Frick Environmental Center managed to score a full points under the water efficiency category, which meets the goals of making the building net zero water.
Wow, what are some techniques that has been used in this building?
The building achieves net zero water through several techniques. Firstly, they reduce water use and demand through reduced flow and ultra-high efficiency plumbing.
I heard that a historical fountain was also planned for the park, but it would require a lot of water to provide the visual and auditory effects.
Yes, so this was achieved by minimizing the volume of water used in the fountain to be only 4 inches deep with a low bubbling jet. Wastewater is treated and discharged on site using an underground treatment system and drip irrigation field. The treatment first separates waste solid from water in the dual vault septic tank with aerobic and anaerobic bacterial digestion.
Oh, the secondary treatment is provided by a recirculating sand filter to further allow for biological digestion.
Finally, the grey water undergoes UV disinfections and is discharged through a hydraulic control unit to the drip field, located within the woodlands where the soils are the most suitable. Agriculture also plays an important role by disposing and reducing demands of water as seen.
I saw that the environmental artist has also designed a watershed sculpture called Falls Ravine that will be activated by rainwater that flows off the roof and through a series of runnels set into the sandstone terrace. The building seems to have many net zero features.
On the north side, we store and treat rainwater for use on site. Designed with a simple slope roof, rainwater falls from the slope roof in a dramatic sheer curtain called the rain veil. There is also a 15,000-gallon underground cistern and a historical fountain which uses the harvested rainwater. There is also rainwater infiltration surrounding the site in the form of previous pavers, and the pond on the south also consists of rainwater filtration system.
Could you elaborate more on the rainwater harvesting system?
First off, the solar panels over the parking lot not only generate energy, it also stores and collects rainwater. The Environmental Center drive and walkways also incorporate 3 areas of previous pavers that allows rains and melting snow to slowly flow into below-grade infiltration basin, where it is filtered and slowly released into the Fern Hollow watershed. Rainwater from the solar panels and nearby barn roof is channeled into 2 500-gallon rain barrels and a 15,000-gallon underground cistern for the potable and non-potable usage. This rainwater is then treated in a 3-stage process, including a 5-micron stainless steel filter and 2 UV treatment units, before it is used throughout the site. Rainwater cascades in a dynamic curtain of water from the building's northern roof edge, called the rain veil. From there, the rainwater channels into the rain ravine, a stepped sandstone water feature, before heading through a constructed series of wetlands. The center is not connected to the city sewer system. Wastewater is treated and discharged on site using an underground treatment system and drip irrigation field.
I see that the building managed to divert a huge amount of stormwater per year and also remove a good amount of total suspended solids. With that amount, it's no wonder the energy usage is so low. The surrounding wetlands and building facade also plays an important role to provide natural ventilation to the building. But how?
Many of the building's windows are openable, so we can take advantage of the outside air temperature for natural heating and cooling.
I see that the building also has high-up windows that open at night during warm weather.
Yes, so hot air can exit the building, reducing the need for air conditioning. The building is oriented in a way that encourages natural ventilation. Cool air comes in on lower floors and works its way through the entire building. The automated skylight creates stack effect. The facade also consists of many openable windows facing the wetland and dense woodlands, which helps maintain cooler air temperature through evaporative cooling.
The prevailing summer wind and winter wind provided by the fenestration of the facade also contributes to maintaining the thermal comfort of the building.
Now, let me explain about the post-occupancy evaluations in Frick Environmental Center based on these three imperatives.
Sounds great.
Frick Park connects 8 distinct city neighborhoods through an interwoven system of public trails. The site is highly accessible by foot, bikes, public transportation, and private vehicle. The center is designed exclusively and focused on the accessibility for all, close to vehicle traffic within the park, and low and obstructive signage promote a pedestrian pace.
Wow, they designed the park truly to encourage people to walk, which reduces carbon emissions.
So, the air quality in the center is extremely good based on the data. As you can see the table above, the air quality index is only 1 US AQI, which also represents good air quality. The surveys show that overall workers' happiness, comfort, and productivity have raised since relocation to the center, while indoor air quality was highlighted as resulting in a superior work expertise. The center also implemented a system called the red-green light system that detects what the weather conditions are outside of the facility. If it's optimal, the green light comes on, alerting the occupants to open the windows, take advantage of the great condition outside.
Wow, they're taking elements from nature as always and use them in a really effective way to use less energy.
The center brings the biophilic benefits of the outdoors in. All regularly occupied areas have abundant daylight, views of nature, and access to fresh air provided by operable floor-to-ceiling wood windows.
Yeah, I heard a lot of good reviews on this.
The center welcomes everyone to experience nature on the site as they desire. From relaxing in the amphitheater on a lazy spring afternoon to tasting a freshly picked tomatoes from the gardens on a hot summer's evening to embarking upon an exhilarating walk with a dog on a winter morning. The building is a stellar exemplar of green architecture and thoughtful design, including benches made from planks of fallen trees recycled for the purpose.
Impressive. Frick really does have it all. We hope that you acknowledge the importance of sustainability in architecture and understand the impact of built environment on the global scene and the energy demands in building.
And hopefully, we get to promote and spread the awareness of sustainable architecture to the other building through this video. Thank you for watching.
We hope you enjoyed the video. See you next time.
Bye!